Swayam Prabha. Digital India. Educated India.
Good morning students, welcome to lecture 10. In lecture 10 we will carry on with our journey into smart and connected products. So at the end of this lecture you will be able to go beyond what we have already covered, which is identifying key IoT characteristics, architecture and protocols and selecting sensors, to actually applying a set of design principles in developing smart products. Okay, so how to systematically create smart products, okay, how to adopt a systematic procedure using design principles to develop smart products. So let us start with a simplified view of IoT. So IoT product can be thought of as a combination of a physical object, some sensors, actuators and controllers, and the internet. Okay, so the physical object could be anything, could be a fan, could be a table, desk, chair, any physical object. Okay, it could be a breadboard. Okay, so that is your physical object, and to that we attach some sensors, actuators and controllers. So you have seen the example of using the ESP32 and the ESP8266 boards. Okay, so these are microcontroller boards which can connect to a Wi-Fi network. Okay, so that is why they have been used in creating these IoT devices. In addition, we have sensors which collect physical data from the environment, such as temperature, humidity, airflow, gas mixtures, whatever. So sensors are there to sense and collect data from the environment. Actuators are there to take an action based on the collected data. Okay, so for instance, motors, those are actuators. Okay, so collection of sensors, actuators and controllers, and of course we need the internet. Okay, because we are creating an Internet of Things product. Okay, so this internet could, for instance, come from a Wi-Fi network. Okay, so this is a simplified view of IoT. We need a physical object, sensors, actuators and controllers and the internet to create a IoT product. Okay, that is what all of you will be doing in your project as well. So something to think about, many of you have given bills of materials where you have mentioned the controller that you want to use, you have suggested you will use the Arduino board, but the Arduino board generally cannot directly connect to the network, you will need some Wi-Fi add-on. So instead what you can do is you can use boards which can connect to Wi-Fi networks, okay, such as the ESP32 and ESP8266, which I have already provided you. So you will be using those boards to create your product. Okay, but in addition to that, if you still need the Arduino board, let me know and then I will get some of those as well. Okay, so for additional processing capabilities, etc., if you need, then we can look into that, but in general the microcontroller units that I have given you should work. Okay. So there are various types of designers for IoT products. There are designers who are concerned with the board system. Okay, so the overall architecture of the board system. Some designers may be concerned with the interaction of the different elements. How do the different elements talk to each other, and how we use that interaction to be able to achieve some functionality. Okay, so maybe the sensors and actuators, they interact in a way that you provide some functionality such as temperature control. Okay, so designers may be concerned with the interaction of the different elements. Some designers may be concerned with the board system, so they will design the board system. Others will design the interaction between the different elements. There is consensus that the design of IoT products goes beyond appearance. The focus is a lot on functionality. Okay, what functionality can we achieve from our IoT product? So the design goes beyond the appearance. Okay, of course, you can make your product look beautiful, but designing IoT products is all about delivering value from functionality. Okay, so the design really goes beyond the appearance. Some key design principles that you need to think about when you are designing your IoT system, and again, these design principles should come out in your practical project as well. So, first is doing the research. So, you have done some basic research in coming out with the system that you have proposed for your practical project. So, this research is key. Okay. So, doing detailed research is key, and sometimes even after you have made your project proposal and you start working on project, you will have to keep doing this research. You have to think about aligning the features with user value. So, what are the features of your IoT product? Okay. Is it able to do temperature sensing? Is it able to control the humidity in your room? Okay. So, and how do these features create value for the user? Okay. So, mapping the features to the user value is crucial. You also want to think about making systems interoperable. Can the different systems talk to each other and operate with each other? Okay, making systems interoperable. So, if you have created an IoT product, can it interface with your smartphone? Can it interface with other IoT devices? Okay. So, are the protocols that you are using in designing your product making your system operable with other systems? So, think about the interoperability of your system. Okay. So, what protocols are you choosing? How common are those protocols? And for your specific application use cases, you might have thousands of users. Are all of these people with different systems able to access the data coming out from your IoT product? Okay. So, think about that. The next design principle is to incorporate security. So, you have data being transmitted from all these sensors. Okay. So, let us say you are creating a digital twin for Siemens. Okay. And the data that is coming out, your company may not want that data to be visible to other companies. Okay. So, you may want that it cannot be hacked. Okay. So, security is key. So, think about security and incorporate it early in your design process. Consider the operating settings of the different features. So, you have created different features which map to user values, but what are the operating settings? Can I measure from -5 to 10 degrees? Can I measure from 0 degrees to 50 degrees? Where am I placing my device? Okay. So, think about the operating settings of the features. Okay. So, accordingly you may choose your sensors and actuators. So, let us say you are going to place something to measure the melting glaciers in Antarctica, then think about the temperature regime there. It will be minus maybe 30 or 40 degrees to as high as 10 degrees. So, the sensors then would have to be operable in those regimes. Okay. So, consider the operating settings of your features. The next thing you want to be doing is deploying effective data management. Okay. So, the data that is coming out from your sensors, you want to be managing that well, because the data that comes out of these IoT devices is immense. So, imagine you are working for Bombardier and Bombardier is making all these immense aircraft systems. So, it will have thousands of hundreds of maybe milling machines in a big shop floor. Okay. So, imagine the data that is coming out, it is enormous. Okay. So, you want to be thinking about how you can manage these large streams of data. Okay. So, your design has to incorporate effective data management. So, as a designer for Bombardier, you will have to think about the data management aspects. Okay. Do you have enough storage capabilities? Okay. Do you have links to data warehouses or data centers where you can or cloud computing facilities which can enable data management? Okay. How do you hook those up to your network? How do you enable the seamless connectivity? The next thing is to think about scalability. Okay. So, can you scale that simple desktop prototype that you have created? Can you scale it to a larger scale? Okay. So, if you are asked to create a product with, instead of 10 sensors, 10,000 sensors, okay, can your system scale, or not. Okay. So, all of these are the key design principles. And finally, you should think about preparing for different use cases. So, maybe you have created your IoT product for a certain specific user scenario. Can you then use it in other scenarios? Okay. So, what we will do today is we will talk about all of these design principles. Okay. Each one of them we will have a look. So, firstly, doing the research. So, what do you need to research? You need to research what is the purpose of this device, why are you creating this device, okay, and who are going to be the users, who are the likely users. Okay. So, for instance, Shubham, you are developing that smart door lock. Okay. So, what is the purpose of the device?
So that we eliminate the keys and carrying keys with us.
Yes.
We can just do it with a smartphone.
Yes. So, you can control the opening of your door in your hostel sitting here. Okay. And who do you think is going to use such smart door locks?
Like, so it would be possible in any case, like in the institution itself, like if there is a, you know, office kind of thing, and if someone wants to open the door, so there's, instead of giving them that cards and keys, they can just make a common software and all, which they, with their fingerprint they can open any door. So it will be enhanced authorization and security.
So, the user base for your smart door lock is really enormous. All the students, all the offices at the institute can use it. Likewise, people who are building smart homes, they would want to incorporate smart door locks. Okay. All sorts of industry settings, again you can monitor all the doors. So, at night time when the factory is closed, are all the doors locked or not? You can go on a web app and you can immediately see the status of all the doors. Okay. If anything is not locked, just click a button and it will get locked. Okay. So, once you know that, then you can also better sell your product. You can market it and sell it better. You must know who would want to use it. So, you have to go outside your comfort zone and think like the device's eventual users to identify how the product will solve people's pain points and help overcome obstacles. So, when you are designing a product, you want to be thinking, well, what are the gaps or pain points of people that your device can help resolve, and what are those obstacles, bottlenecks they have that your device will solve. So, do not start with any assumption of what features end users need. Okay. So, do the research, do the user research, do the market research. Okay. So, that will tell you what features are needed. So, research the target audience to see what products and experiences exist and how the IoT device can make users' lives better. So, you need to research your target audience to see what products and experiences already exist. Okay. So, doing a market research, let us say going on eBay or Amazon or Flipkart, will also tell you a lot about what kind of products and experiences already exist, brochures, company brochures, etc. So, look at that to find out what experiences exist and how your device. So, there is no point connecting a product to the internet unless it actually makes the lives of people better or easier. Okay, think about what is the advantage users will gain from your product. So, last week I passed this around. So, this is a 12-year-old kid, his name is Himesh Chadalavada. Okay. So, he witnessed his grandmother struggle with Alzheimer's. So, her grandmother was old and she had no control over her mind and body. So, she would sometimes leave her bed in the middle of the night, and the family had to spend the rest of the night trying to find her. Okay. Himesh is now 16 and he recalls this struggle and it affected him a lot. So, he wanted to help his grandmother and also his family. So, he embarked on a mission and created a smart wristband. Okay. So, at the young age of 12, he created a smart wristband. So, if he can do it, what can you not do? Okay. So, this is unstoppable 21 Indians under 21 years. So, you can be a future unstoppable 21 Indian. Okay. So, So, he has created what is known as the alpha monitor, okay, and lots of people are praising it, and it is helping the elderly who are afflicted with dementia, and in the internet is being used to help such users. Okay. So, there is a lot of potential in the healthcare field. India has a population of more than 1 billion, and people need such smart devices, okay, to make their lives easier. So, think about such use cases, and if you can imagine it, then you can create the product. The key is to understand what does the user need, and you must have some motivation, real desire, a fire in you to be able to help people with the problems. Okay. So, you can not only help people, you can also help animals and other living creatures. So, you can really create a lot of smart devices that can change our world. So, you can see here he is planning to launch the alpha monitor in the next 6 months, and he is doing some research at IIT Delhi, okay, and he is getting some patent etc. for that, okay, and he has been given a grant of 33 lakhs at the even before starting university from Samsung and IIT Delhi. So, if you can create something like this, imagine the potential for yourself. Okay. So, next design principle that you need to think about is aligning features with user value. So, IoT users aren't always aware of what value their devices can provide. So, they don't know what value their devices can provide. So, users may be reluctant to adopt a new IoT product because it addresses a problem that they are not familiar with, or they are unclear how to address the adoption barriers such as cost, usability or security concerns. So, of course, the IoT product might be more expensive than a normal product because it has integrated electronics, it needs connectivity to the internet, etc. Okay. So, people may be just shy and reluctant, and what is this high end technology, do I really need it? So, you need to think about the user value. What is the new value that the user is getting from the features that you are providing? Okay. So, previous research can help designers discover which end user problems are worth solving with an IoT device and what value it provides. Okay. So, you can look at previous research. Past research is at the tip of your fingertips. Thanks to the internet, you can go on Google Scholar, you can go on just Google and search engines. There are lots of white papers published by companies. Okay. So, there is a ton of research that is available just at your fingertips. Okay. So, that can help you as a designer discover which end user problems are worth solving, which are the problems that people have looked into deeply in the past and developed many different solutions with IoT devices, and what are the values it has provided, what is the value that these previous solutions have provided. So, that will give you ideas about what values you need to provide with your product. Okay. So, if your product's feature set aligns with these problems or barriers, then it will be easier to sell. So, taking a lot of time to understand the problems that people are facing. So, Himesh could understand that his whole family and his grandmother both were facing problems. Okay. So, and he was really motivated. So, understanding the problem will create the motivation in you to create a solution. Okay. So, next thing that a designer needs to think about is interoperability. So, interoperability is nothing but the ability of two or more devices, systems and platforms or networks to work together with each other. Okay. Two or more devices, systems, platforms or networks to work together. So, you have created one IoT device, Raja at the back, he has created one IoT device. Okay. So, these two devices, can they talk to each other? Can they work with each other? Okay. Can they get on the same network? So, think about that. So, this is determined by the ability of a system to exchange information with other systems and make use of it. So, can your system pass on its data to other systems where the users are present and make use of it. So, interoperability enables communication between heterogeneous devices or systems in order to achieve a common goal. So, different devices which do different things. Okay. So, these are heterogeneous. Okay. They are devices which do different things and are connected to different networks. Can they communicate with each other? Okay. So, current devices and systems, because IoT has just grown randomly in different parts of the world. So, current devices and systems are fragmented with respect to these communication technologies, protocols and data formats, and that is where the research comes in. There is so much opportunity for you all to get into IoT as a research theme as well, to do research in a research lab like IBM or Intel, or even do research at universities, okay. Because there is a lot of fragmentation with respect to communication technologies, protocols. So, we talked about IEEE protocols and all different types of protocols, yeah, and there are lots of different data formats. People are storing the data in many different formats. So, current devices and systems are fragmented, and there is a need to create this unison, to bring them together and make them work with each other, or interoperable. Everyone understands what interoperability is? So, there is a lot of diversity, and that makes it difficult for these devices and systems in the IoT network to communicate. That communication between different devices, between your device and Raja's device, becomes difficult, because systems are not interoperable and they cannot share data with one another. So, that limits the utility, the usability, the benefits that we get from these IoT networks. Okay. So, let us look at an example. So, this example is known as Megan. Okay. So, to create this interoperability, so people some researchers at I believe IIT Kharagpur, they have developed this device known as Megan. So, Megan stands for multi-purpose, energy efficient, adaptable, low cost sensor node. Okay. It is not the name of a girl, it is the name of a IoT node. Okay. So, this is the product that they have created. So, you see this low cost sensor node they have developed. There you have this main processor, and this processor is just like the microcontroller unit that I have given you. Okay. So, the ESP8266 boards, it has a USB interface. Okay. So, you can connect it to USB devices like your laptop. It has some external switches, it has some LED indicators, just like the LEDs we worked on last week. It has some ports for programming, it has a reset switch just like the board that you have got. It has got wireless module ports, it has got some actuators, it has got some sensor ports, and it is also connected to a LCD display. Okay. And then there is a voltage regulator which is controlling the voltage of these sensor ports and also the wireless module ports. There is a power management circuit that is connected to a power output rail. So, the power is coming in from somewhere, it is going to a power management circuit, and then that power is being fed to the LCD display, it is being fed to this processor unit, and it is being sent through the voltage regulator. Okay. And this voltage regulator is then sending the power to these ports, which are then connecting to the processor. Okay. And then so this power management circuit is drawing its power from a rechargeable battery, which of course is getting charged from some DC input using a charging circuit. Okay. So, using just DC input, you are able to run this processor, and this power unit is connected to the wireless communication unit, the processing and memory unit, and sensors and actuators. So, it is powering the power unit is powering 3 different units, and these 3 units are talking to each other. Wireless communication unit for wireless communication, communicating with the wireless network, the processing and memory unit, and that is communicating with this, and also the sensors and actuators are communicating with this. Okay. So, all of these are integrated in this low cost sensor node. So, the architecture of Megan has sensors and actuators with 32 general purpose input output pins. Okay. Different peripheral interfacing communication protocols can be used on this low cost sensor node. So, there is interoperability of all of these communication protocols. So, they have created chips such that digital serial peripheral interfaces, inter-integrated circuits, so I2C circuits, analog to digital converters ADC, and universal asynchronous receiver transmitter. So, that micro USB port, UART port. So, all of these are can be incorporated in this low cost sensor node. The processing unit has a ATmega 324PA processor, which is a low power, high performance, reduced instruction set computer based processor. Okay. So, this particular processor they have used. So, this processor has a lot of features. So, it has 32 general purpose input out pins, ADC, I2C, UART, SPI, a timer and a counter, and there is pulse width modulation. Okay. So, you can control the width of pulses using this board. There is a joint test action group on there as well, little chip. There is flash memory, there is static RAM, and there is electrically erasable and programmable ROM. So, it's almost a low cost computer. So, it is a reduced instruction set computer. There are 2 UART channels, 2 micro USB channels, which are required to make a separate channel for communication for the communication unit, and there is a USB port. So, lots of different features on this one sensor node. The memory unit is comprised of 3 units: flash memory, fuse bit, and EEPROM. The flash memory stores executable files written by the programmer to serve the applications. So, there is a flash memory on it, and there is a fuse bit which is used to configure the processor with respect to the hardware clock frequency, the boot reset vector, and the watchdog timer. So, there are 3 things in there. There is a hardware clock frequency, there is a boot reset vector for resetting, and there is a watchdog timer, there is a timer in there. Okay. So, all of this forms part of the memory, okay, memory unit of your low cost sensor node. And they have got a EEPROM which is temporarily used to store the sense data. So, if you are electronics engineer, you will probably understand a lot of this better, but it is just useful for you to know as a designer what are the things, what are the sorts of things that can be built into a more complex IoT product that is interoperable. So, the power control unit manages the supply side of the entire node. The onboard power supply unit has rechargeable batteries, you saw that, okay. And then there is a recharging circuit, and that is integrated on the sensor node, which allows charging of the rechargeable batteries, and that is by supplying power through the DSC connectors. Okay. Then there is a communication unit that consists of a transceiver responsible for the reception and transmission of signals to and from the sensor nodes. Okay. There is a wide selection of wireless communication protocols. So, you can use many different wireless communication protocols such as Bluetooth, such as Zigbee, general packet radio service, radio frequency identification, okay, Wi-Fi, GSM. So, all of these are available on that low cost sensor node. So, this is how they have realized the interoperable system. This is a processor unit of Megan. It has, as you can see, 40 pins, of which 32 GPIO pins, general purpose input output pins. Okay. This is the power management circuitry, and this is the charging circuitry. So, this paper is available on the web. So, do have a look. This can form part of your external reading, and you can do some reflection on it, include in your portfolio. So, please open your smartphones and have a go. Okay, can you see? So, let us say I go in here and I upload my picture. So, you see it has been able to detect my face, okay, and it gives some output here, which is telling me, okay, with 89% confidence, it is telling me that this is my face, okay, this area that it has marked out, okay, and with 31% confidence, it is saying I am a male, okay, and then it is saying it has got my age nearly right. So, you see, so it is predicting my age to be 39. So, it says I do not have a mustache. So, that is correct with 30% confidence. It also tells me that I am an Indian, which is correct. Okay. So, and then my mood is neutral, indeed I am neither happy nor sad, and that is it. So, the key thing, it was able to say that I am an Indian, that I am male, and that my lips are sealed. Okay. I am not using any glasses. Okay. My eyes are open. Okay. So, you can see the intelligent detection ability of this product. Okay. You can think of this as a product, which is, you can also think of this as an IoT product in a sense, okay, virtual product even if it is. So, have you tried it on your face? You can literally take a picture now, and does it give you any other nationality other than Indian? Anybody got any other nationality, or anybody is male and was predicted to be female, or female to be predicted as male? So, have a go.
Not showing.
Ah, okay. So, you really have to hover your mouse over it, and then my mouse is in this box, you see the cursor, and that is when it shows this. Is it detecting your face correctly? Little off center, okay. Depends on the lighting, of course. This, of course, is taken by a professional photographer. So, so I was on a trip to Matlock, which is about an hour from Nottingham, maybe about 7 or 8 years ago. Oh no, then this age is wrong, isn't it? This is an old picture. So, it's just a bit off. It's not showing me to be 10 years old or 90 years old. Okay. Sorry?
50 years old.
Ah, 50 years old for you. So, yeah, it's probably not very well trained on Indian images, or but it probably does get trained when you upload your images. So, any other interesting results? No? So, it's because of the lighting. There is no not much lighting over there. So, anyhow, 97%. Wow. I am Indian with 91% confidence. Okay, that's good. So, you can play with this later. So, there are lots of such products available now, okay, which are really useful. Okay, so, and due to such products which are getting increasingly smarter thanks to AI and ML techniques, so we are heading towards a really smart world. Okay, so we are already living in a smart world. So, the next thing that a designer needs to think about is information transparency and security. So, connected devices over the network, they share information. Okay, when devices are connected over the network, they share information. The physical process gets recorded and gets stored virtually. Okay, so once you have connected your device to the network, this physical process which you are monitoring, that gets recorded and stored virtually, such that all the stakeholders who have an interest in that product or in that device can access this data. So, it raises key challenges of security and privacy of the information that is processed by the IoT devices in our daily lives. So, users are usually unaware of the personal information collection and transmission activities that affect their security and privacy. Okay. So, we are using a lot of IoT devices all the time now, even we are unaware that our personal information has been collected at different places. So, there is a need for a solution that increases the privacy and security of data in IoT devices through a system that controls the IoT devices communication on the network. So, we need to control the communication of these IoT devices on the network. So, for information transparency, some of the key design principles are: first, that the IoT device manufacturer must declare the device's data collection intention. So, if you have created an IoT product, so you must clearly state, okay, this is the data that we are going to collect, and declare it clearly. Second, the user must declare their own preferences of what is permitted to the IoT device. So, the user must say, okay, of all of these things that manufacturer is, the device is going to collect, what are my preferences, which data I will allow, which data I will not allow. That option must be given to the user. So, design of the system includes tools that are capable of analyzing packets. So, you must design the system such that the packets sent by the IoT devices can be analyzed, and you can apply network traffic control rules. Okay, so, you can apply a set of rules that control the traffic on the network. Okay. So, the objective of doing this is to allow the declaration and verification of communication intentions of IoT devices. So, to declare that these are the intentions of my IoT device. So, the IoT device which is communicating, these are the intentions, and these intentions must be verified by the user. So, user must verify them, and the user must be able to control the communication of such devices, and we must be able to detect security and privacy violations. So, if there is any violation that occurs, we must be able to intelligently detect, and that is why there is a lot of research potential. All of these things are still not established. There is so much research that can be done on security. Coming to, as a designer, how will you set the operating settings of your features? So, you need to think about combining your digital and physical components well, okay, because the digital world can affect the physical world, the physical world can affect the digital world. Okay. So, let us say the fan breaks down, with it your sensors etc. may also suffer, okay. Or if the incorrect information is transferred from the digital to the physical world, then you might have your product operating at settings which you did not intend, okay. So, both the digital and the physical components can affect one another. Again, devices that can function on low power are different from the ones that must be weatherproof or one that accommodates multiple end users, okay. So, there are different types of devices. So, functioning on low power is a certain kind of operating setting, making them weatherproof is another type of operating setting, or accommodating multiple end users is another type of setting that you may have to enable on your device, okay. So, think about what functionality that your device will have. Will it function on low power? Will it be weatherproof from rain, storms, etc., or does it have to accommodate multiple end users? So, what are the functionalities, and based on that you will determine your operating settings. So, by developing timely and purposeful features with wide and precise operating settings, you can give the user value. So, you need to think, do I need the device to operate between minus 10 degrees and 50 degrees, or do I need to operate only between minus 5 and 10 degrees? So, for instance, if you are putting some temperature sensors in a refrigerator, it is unlikely that the temperature inside the refrigerator will ever exceed 10 degrees. Also, it is unlikely that it will fall, if it is not a freezer, if it is just the fridge compartment, then it will not fall below minus 5 degrees. So, you need to have a temperature that a sensor that works in that range, okay. And also you may need precision, you may need information up to maybe 0.1 degrees Celsius, okay. So, precise operating settings and the range of the operating settings, think about that as a designer, okay. So, it must fit the considered use case. What is the functionality or the use case that you are trying to achieve, and how will that give the user value? Based on that, you must have the features with the appropriate operating settings. Also, these operating settings give the end users the knowledge of how IoT can solve their problem. So, these settings will tell them, okay, so by looking at the specs of your IoT product, the user will be able to say, well, yes, it operates in the range that I want it to operate and will do the job for me, okay. Next thing the designer needs to think about is effective data management, which is to consider that IoT devices generate massive amounts of data regularly, especially if they are always connected to the network. They are continuously streaming data. So, you need to deploy effective data management workflows very early in your design process and often. So, regularly deploy these data management workflows. Designers who understand how the device generates data are better positioned to develop the right systems and integrations to efficiently gather, store and transmit the data. So, if you know how the device is generating the data, what sensors it is using, what protocols it is using for transmitting, how often it is collecting the data, how often it is transmitting the data. If you know all of that, then you will be able to develop the right system and integrations. So, if you are picking up a particular sensor from the market, a particular actuator, a particular microcontroller, you must know how it is generating the data, how this sensor is generating the data, how often it is generating, okay, and how much data it is generating. So, you will be able to reduce the data latency to realized reduced transmission loads or increase the bandwidth for peak use times. Okay. So, if you know how much data is transmitted and how often, you can reduce the latency, the delay in the data being transmitted. You can reduce the transmission load. Okay. You can transmit optimally how much, just the amount of data that you need to make the correct judgment. Okay. And you can also increase the bandwidth. So, maybe during 9 to 5 when the factory is open, okay, and workers are working, products are being manufactured, that is when you need the increased bandwidth. So, you can increase your bandwidth during that time period. The next thing you want to think about is scalability. So, IoT devices are often used in multiples for enterprise deployments, which means there are thousands of devices to simultaneously gather, transmit and receive data. So, that makes what is known in IoT parlance as device fleet. These device fleets must connect and integrate with each other easily and the larger corporate network. Okay, they must connect and integrate with each other easily and the larger corporate network. To ensure scalability, the product designers must incorporate the appropriate gateways and management software to handle the fleet and data connection. Okay, so, you may have to incorporate appropriate gateways and management software, okay, to handle all of this data and make your system scalable. Okay. So, if you have designed a product for use on a single machine tool, can you scale it up to 100 machine tools? Okay. So, for that how much storage do you need? How many buses do you need to transmit the data? Okay. How many routers do you need? Okay. All of that is what you as IoT designer have to think about. And the developers, they should include easy connection options. So, to be able to connect easily and set up wizards for IoT devices, so that it becomes easier to scale IoT deployment. So, if your interfaces that you are using are simple enough, then even workers with low levels of training, they can deploy these IoT devices easily. And finally, you need to prepare for different use cases. So, you must expect the end users to implement IoT devices in unexpected or unintended ways. Okay. So, for instance, a doorbell camera can be repurposed as an IoT device to control access to people. You can have actuator control devices that control industrial machinery instead of operating doors. Okay. So, new use cases for your device. Okay. So, you may have designed your device for a certain purpose, but people may take it and repurpose it for other cases. So, think about how you can make it usable in multiple different ways. So, your device, if it can be used in multiple different ways, then your device will gather a lot of interest. So, use case flexible IoT devices have more adoption success, more people start using them as end users can expand the products used on it. So, once it becomes popular as a different use case, then lots of those such interested users, they will come and buy that product from the market, okay, for a use case that you may not have even thought about. Designers can track these user generated ideas. So, users also generate ideas. So, if you look at, so once you have you have created and developed a new IoT product and you have launched it on Amazon or eBay, then you look at the feedback. So, these users, they will generate ideas for the use of your product in many different ways. Okay. So, you can track them and you can incorporate them into future device versions. So, if you look at the feedback on your own product, then you can get some ideas about how you can design your future products, or you can support these new use cases. So, maybe lots of people are using it for a new application, then you can create a team that can help such users. So, to summarize what we have learnt, so the key design principles for smart and connected devices are doing the research, aligning the features with values for the users, making the systems interoperable, incorporating security, considering the operating settings, deploying effective data management, including scalability and preparing for different use cases. Okay. So, these are the things you as a designer have to think about. So, when you are given to design a new product, be it for this course or later for the industry or as a part of a research team, these are the things that you must think about deeply. You must really think about them, reflect on it, make notes and change your designs accordingly, so that your product becomes really useful and beneficial. Okay. So, you need to think like the device's eventual users to identify how the product will solve these pain points and help overcome obstacles. So, think about the pain points. So, if you think about this kid Hamish, so he thought about the pain point for his whole family, which was his grandmother was going missing in the middle of the night. So, think about those pain points and how your product, the smart wristband, solve solve the pain point for his family. Okay. So, I have some tasks for you. So, these will get you more familiarized with that little LED web server that you have built. So, modify the code for the LED web server such that it can show the status of 3 LEDs instead of 2. So, you have done it for 2, make it for 3. Okay. So, there must be 3 buttons. Okay. Then take a picture and include it in your portfolio. Okay. And then you can create nice videos as well, and you can upload these videos to YouTube, and you can include that link of that video that you uploaded to YouTube in your portfolio. Then I will go and have a look. Okay, you can do that. So, create a LED web server. So, you can start your own channel. So, maybe if you say some interesting funny things, that channel also becomes popular. So, IoT also gives you the opportunity to learn yourself and teach others also. Okay. So, create this learning community. So, create a LED web server where there is only one button. On click, it must go from on state to for all 3 LEDs to offset. So, 3 LEDs again, but all 3 will be on or all 3 will be off using one button. Okay. Then create a display of LEDs going to on one at a time with a time gap of 1 second when the user clicks. Okay. So, user clicks, then red glows, okay. Then after 1 second the yellow glows, then the blue glows, then red, then yellow, then blue, until the user clicks again, and then the whole thing stops. So, try to incorporate that functionality. So, the next thing, will understand how the code works. Okay. So, if you go through a code, you will see the first thing you need to do is include your ESP8266 Wi-Fi library. So, for that the command is #include ESP8266 Wi-Fi.h. Okay. So, this is important because you will write codes for many different sensors. Okay. It is important to understand this code because you will write codes for many different sensors, and unless you understand what each line means, then you will not be able to make changes and write your own code for your project. Okay. So, the first thing you need to do is include the library for this board. Okay. The Wi-Fi library for this board. Yes. Okay. How about this? Okay. So, include the Wi-Fi library, then insert your Wi-Fi SSID and your password, okay, based on the hotspot that you have created. Then set your web server port to 80. So, for that the line in your program will be Wi-Fi server bracket 80. Okay. So, that is the port through which it runs. Then create a variable to store the header of the HTTP requests. So, string header, everyone understands, just like you say int A, int B, like that string header. Next, create some auxiliary variables to store the current state of your outputs. So, you can say string green state is equal to off, string red state is equal to off. Okay. So, you start off with a off state for your LEDs. Okay. Then assign the pin numbers, okay, to each of your outputs. So, constant int green LED is equal to 5, constant int red LED is equal to 4. Okay. Then go into setup. So, there is a setup function next. Okay. So, there you need to set the baud rate at which the communication occurs. So, for that you need to place a line that says serial.begin and the baud rate. Yes. So, this is the rate at which there is communication between the laptop and the board.
It's a time unit.
I believe it is in hertz. So, how fast it is, rate, okay, per unit time. Okay, so then, so for the green LED and the red LED, you can set the pin mode. Okay. So, define your GPIOs as output. So, this is where the output of your board will be. Okay. So, define these pins to output and then set them to low. Okay. So, using these commands, digital write, you can make it glow or you can make it turn off. So, when you say green LED low, that means green LED will be off. When you say green LED high, then it will be on. Okay. So, digital write, the name of your output device, which is the green LED, and its state, whether it's low or high. Then you have a set of lines to begin the Wi-Fi connection. So, for that you need Wi-Fi.begin SSID comma password. Okay. Now, you just gave the names for your SSID and password before. You just stated what is the SSID, what is the Wi-Fi name and the password. Now, you are beginning it. Okay. In setup, you are setting the whole thing up. So, you are saying Wi-Fi let it begin with this SSID and password, you have declared them previously. Okay. And then, when the Wi-Fi status is not connected, just wait for 500 milliseconds and print this. Okay. So, if it is not connected, then you need to do this, so that the user knows. So, it shows up in the output screen that okay, so we are just trying to connect dot 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 dot. Okay, it is trying to connect. So, the board is trying to connect to your Wi-Fi hotspot. Then once it is connected, say Wi-Fi connected, okay, and then declare the IP address. Then there is a loop function. In the loop function, we program what happens when a new client establishes a connection with the web server. Okay. So, if the connection is established, that is what we need to program. So, we need to set up this Wi-Fi client. So, we need to listen for incoming clients. For that, the line is Wi-Fi client. So, this is the server. So, the board is a server, the client is your smartphone. Okay. So, just like in a restaurant, there is a waiter and then you are the client. Okay. So, your client is asking for something, your web page is asking for the status of the LEDs. Okay. So, your web page is a client. So, for that, create an object and make it available, so that the server is available. So, listen for incoming clients, and then when a request is received from client, we will save the incoming data. So, there is a while loop for it that will be running as long as the client stays connected. So, as long as the browser in your smartphone is running, so the while loop here will keep running. So, do not change this part of the code. So, this is if client, then print new client. Okay. So, in the serial port you will see new client appear, and then you can, so while the client is connected, you can then read a byte, okay, and then print it out a serial monitor. So, that is why you see all those messages come up in the serial monitor. Okay. So, this bit here you do not have to worry. Okay. So, declare variable C of type character. So, that is reading the client, then it is writing whatever it is reading, the byte. Okay. But if this character is \n, okay, if the byte is a new line character, the current line is blank, then you get 2 new line characters in a row, that is the end of the HTTP client request. So, send a response. If current line length is 0, then you can print HTTP 1.1 200 OK. Otherwise, you print context type text/HTML. Okay. So, these are you don't have to worry about it, just prints out. Okay. So, do not worry about this. In the next section, there are if and else statement that check which button was pressed. So, this is important in your web page and controls the outputs accordingly. Okay. So, if header dot index of this GPIO pin, okay, is greater than equal to 0, then you can print out that GPIO 5 is on. Okay. So, the state of the green LED is on, then you write green LED is high. Okay. So, if button is pressed and it was off before, and then it will go to high. Otherwise, if the off index is active, okay. So, if off is activated from your, so if you click and off becomes activated from your browser, then you have to say GPIO 5 is off, and then you have to write low and turn it off. Okay. So, if you get the off command from your finger, then it sets the green LED to off. So, green LED becomes off. So, this is how it is occurring. So, this is crucial. Okay. So, if you press on the on, okay, if it was off and you press, so it realizes that it is now supposed to go into on state. So, it prints that out into your output screen, and also it turns the LED into the high state. Otherwise, if it was on and then you have pressed, then it goes into off state. So, this is the crucial bit. Okay. So, likewise for the red LED, you can turn it on and off. So, if you press the GPIO 5 on button, the URL changes to the ESP IP address. So, the IP address which was 192 dot whatever /5/on. Okay. So, the header changes, and that header, based on that header, you are making the changes to the state of the LED. Okay. So, next thing, generate the web page. So, the ESP8266 is sending a response to your browser with some HTML text to display the web page. Okay. The web page is sent to the client using the client.println function. Okay. So, here, so all HTTP pages, they start with this kind of a header. So, and then, so the following line makes the web page responsive and in any web browser. So, you need to, so you are printing this out. Okay. So, head and then the meta name, the content and the initial scale. Okay. So, this is all HTML basics. So, those are the things that you print out, again using this program which you have written in Arduino. Okay. So, you are generating a web page by writing a program instead of creating a HTML file where you type out the text. Okay. So, this program is generating the web page for you. Okay. And then you can do some styling, you can set the font, okay, using this line, okay, in your program. So, font family you can choose Arial, Helvetica, Times New Roman, etc. Okay. And then you can do some styling, where to align your text, buttons, etc. So, style your buttons with some properties to define the color, size, border, etc. So, for the button you can set the background color, border, etc. Then for the second button do the same, and then you saw that web page start with ESP8266 web server. So, okay, or you can type in something, your name, your IoT portal. So, I have typed in Amar's IoT portal. So, you can do that. Okay. Then display the current state. Okay. So, current state is written in fine print. So, you can display that on the page, then display the on and off button. Okay. So, for that again this is what you need to print out. ahref is equal to this on button. Okay. Use this button class. Okay. And so this is creating the button. Okay. And you are creating two buttons, one is the on button and one is the other is the off button. Do the same for the other pin as well, other LED, and then finally, when the response ends, we clear the header variable, okay, set it to this and stop the connection with the client with client.stop. So, that is the full program. So, maybe some of it is just a bit puzzling and confusing to it, but just try to make sense of it in natural language. You will get printouts of the practical when we go in there, and then you can run and understand your first project successfully. So, a code is also listed, okay. So, to help you follow, and we will now go in and do this, okay. Any questions on this practical? We took a bit of time, but these are the fundamentals. If you understand the fundamentals, then everything else becomes easy. Okay, any questions on today's lecture?